Okay, so to connect to the Speedgoat, we have the BNC cables connected to the back of the Bentley proximity probe proximeter assembly. Those three, we're doing one location on the shaft right now. So we have the inboard horizontal and the inboard vertical sensors here. Those are connected along with the key phaser to the Bentley oscilloscope interface. And it has four inputs for the proximity probes, horizontal, vertical, and key phaser. And on the front of it, you can adjust the offset, so that allows the signal to be read by the Speedgoat in a good range.
Talk about how when the lights are off, then we're no offset.
Oh yeah. So then these lights are, if you adjust it up, you'll see that there's a positive bias there. The output has a positive DC bias, is what that means. And same for if you go too far negative, it'll have the green light will show up, and that indicates that there's a negative DC bias in the output. So the idea is you just adjust these until you have no lights, and there's a little bit of a range in which you can do that, but that should be that range should be enough for the Speedgoat to handle and still be in a good range. Do that for both horizontal and vertical. And then in the back we have the output to scope is what we send to the Speedgoat, and we also send it to an oscilloscope here just so we can verify that the Speedgoat was working properly. So we've got the green trace is horizontal signal, the yellow trace is the vertical signal, and the blue trace is the key phaser. And all three of those are the two scope outputs on here. So that removes the DC bias, so that's easier to see with the scope, and especially on an XY plot, and just gets it into a good range for both the oscilloscope and the Speedgoat. Back here we just have a slow roll running, so on the speed control, it's running about 250 RPM, and do a ramp, and you can do a speed ramp on that to capture the data. And this is necessary because the Speedgoat only has an input voltage range of plus or minus 10 volts, but depending on the gap of the proximity probes here, if that gap is large, the voltage can be a pretty large negative voltage. You're seeing somewhere around negative 13 volts, so which is not easy to deal with in the system. Then these outputs are split off, so we were looking at them on the scope there, but the main thing we're concerned with is that they connect through these cables, through the BNC splitter, over to the Speedgoat here. And then on the Speedgoat side, we have this. This is the I/O module for the Speedgoat. And the main machine looks like that. That's connected back here with these two cables, which are supplied with the I/O module for the Speedgoat. This is an analog and digital input and output. So it has several channels, but we're using 3 analog inputs right now. We have to connect to these terminals here. So the way that we do that is just with wires and these BNC adapters, which have a screw terminal. We screw in the wires, connect those to the Speedgoat, and then the BNC cables can connect through the splitter back to the oscilloscope interface. And then on Simulink here, we have a pretty simple Simulink model where the Speedgoat has the IO191 module set up, and then we have this analog input module, which change the settings in here. Yeah. You can change the settings in here. You can go on analog inputs. We have 3 channels, and our input range is plus or minus 5.12 volts for all of them. That's been working well for us. You can do smaller voltage ranges, but it's at residence of the shaft. These ones will get up to about there until the key phaser. So I think that's about where the maximum output from the oscilloscope interface is going to be at. We also have analog outputs available, which maybe we could use in the future. And you also have digital I/O. These channels are all set up. Channels 1 to 8 set up to be output, and then they're set to be 0 right now. So on here, we're just using those as grounds. So we set them to 0, and then we measure the analog voltage relative to there. I'm not sure if that's the best way of doing it or not, but it's working for now. And there's also a differential input mode, which you might be able to use in the future. But the rest of the connections are these 2 cables to the I/O module ports, A and B, and then the Speedgoat connects to the computer through an Ethernet cable. So that connects to this computer back here, which is, this is the only computer that we have this proper Speedgoat Simulink software installed, but we can install that software on other computers as well. We just need to get the license. This scope was borrowed from Andrew's thesis project, but you should be able to use any oscilloscope here. The ones in the lab should work well. The ones that came with the Bentley, used with the Bentley kit, should be really good ones to use in the future as well. And once the Speedgoat stuff is all set up, this won't really be necessary. This is just for verifying that everything is okay. And I think that's all the connections.
Yeah, I think you got everything.